Hi everyone. Just let me know if I'm holding the mic close enough. Here, here, here. Great. Yeah, a bit ironic that Android developer is hosting an iOS talks, but whatever. Anyways, my name is Kristijan. I'm from Zagreb. I've been an iOS developer for past 8 years. Wow. Anyways, yeah, usually I come to Ljubljana for concerts, and now I'm the one holding the mic. Hopefully there won't be any singing, at least not from me. Yeah, hi fellow iOS developers and those who want to become one or feel like it. Today I have a pleasure to share some hard-won lessons that I got while working on IoT apps, and of course some hard truths about building IoT apps. But let's first define what an IoT or Internet of Things is. Basically, we have a device, a cluster of devices. Those devices use some technology that facilitates communication with those devices. There is some cloud involved that gathers all that data, and of course, there is probably an app, a mobile phone that also facilitates that through some another technology. And basically, what is like the most important thing for us here is what is an IoT app. Basically, it's an app that connects to physical devices. It reads real-time data, for example, from sensors. It can send commands and configurations to configure your devices, to give them some tasks. It can handle the status of the device, the firmware version, some updates, and of course, keep in track everything that's on the cloud. A simple example of such an app would be, for example, you have like a mesh network of IoT devices. They communicate with each other, probably using some protocol, Zigbee or Matter, that's currently like the industry standard. There is a cloud, and of course, there is an app. And in this example, for example, this app is using Bluetooth to communicate with some of the proxy devices in this mesh network to gather some data and, of course, push it to the cloud. Simple. Well, at least it sounds simple. Usually how you would start the development of such an app is with a proof of concept. And how that starts is the client will tell you some great stories about the device that is going to send you, and then you finally receive this device, and this device doesn't look anything like the final product. It has some wires sticking out of it. It has a separate manual that's titled How Not to Get Electrocuted by This. And when you start to dabble in the features of that device, you see that maybe it doesn't really behave like it's specified. It does crazy things, and of course, you're a developer, you have a deadline, and this is like your first reality check. The unpredictability of that device meets your tight deadline, most likely. You're gonna encounter like 3 problems, definitely. The first one is, I like to call it a broken telephone, like that game when you used to play as a child. Every developer, vendor, whatever, is going to interpret the gray areas of specifications differently. That's just the nature of it. And with, for example, Apple being Apple when it comes to Bluetooth, if you diverge from Bluetooth specification just a tiny bit, guess what? Your connection is gonna get dropped. Bam, gone. Apple is gonna also obfuscate a lot of your data for privacy reasons. For example, on Android, they say, hey, we know this data is on 15 byte. Great. On iOS, we don't know where it is. It's offsetted. We don't know. And of course, the third problem is works on my machine. Your QA is probably going to test your app. You're going to have like a tough relationship with your QA, even with your fellow Android colleagues. Something is going to work on your device. It's not going to work on theirs. Just like it's going to be a chaos. But it's not all that bad. Some expectations that you have from your POC is that you're gonna have a glimpse of your future architecture. You're gonna like build something innovative and stuff like that. It's gonna be the most beautiful code. But in reality, you're gonna have one delay that you know where is it coming from, because it's probably some known firmware issue, and you're gonna have a bunch of random delays that nobody can explain that are barely holding your code together. But at least you proved the concept right. Anyways. After that, there is a honeymoon phase. The client realized, hey, let's define like a minimum viable product. Let's define the deadline that's probably reasonable given the circumstances. You're gonna research about a lot about third-party libraries, or maybe implement your own. You're gonna define architecture, and most importantly, what you learn from your POC phase is you're gonna have a lot of mocks, because you need something to be deterministic in this chaos. This device won't behave like you want to. On some random Friday, your Bluetooth is going to throw some random tantrum and something is not gonna work because somebody is microwaving popcorn for the movie. And that's just the nature of this work. Mocks. Mocks is the way. You're gonna define some architecture. You won't overcomplicate, you're gonna keep it simple. You say, okay, I'm gonna have my core business logic in some SDK. I need three things. I need to communicate with the device, I need to store some data locally, and I need networking. And you're happy. Like you are implementing features left and right, and everything is great. The honeymoon phase just like seems like it's gonna last forever. Like those sirens. But yeah, your app is gonna finally end up in the field, and you're gonna get a bunch of Jira tickets that are gonna keep you awake at night. Something like Bluetooth connection fails. No explanation, it just does. And sometimes, over the weekends, and you don't know why. And you're gonna get a bunch of issues like this that you just won't be able to explain. But your secret weapon is you just need to log everything. You won't be able to explain absolutely every issue. Like, heck, you're probably gonna get answered like just a few of those because you don't know what's happening. Is somebody microwaving something? Is somebody like, I don't know, doing some handover with their Apple devices? You just don't know. So, lessons learned, log as much as you can. Of course, not everybody is an iOS developer. We produce bug-free code from our first attempt, and we don't even need tests for that. Unlike us, firmware developers, another story. Like the worst issue you could have on an IoT project is to have a firmware issue, because it's extremely difficult to recover from that. And what's gonna happen is, okay, they're gonna push a new version of firmware, and then how are you gonna like get that to the clients who already bought the device? You need to like tell them, hey, you need to update your device. You need to do something. Or like a scenario that the devices are not sold. It's in your warehouse, but you have like thousands of those. So you need to do like a bulk of a lot of OTA updates like over the air. And it's a lot of manual work. And I don't want to point any fingers, but America doesn't like updates. They just don't. They don't want updates to be forced on them. So you also need to keep in mind that these things need to be backward compatible. And unfortunately, in probably 99% of cases, at least in my experience, this burden is going to come to your shoulders. It's easier to fix this stuff on the app side. It's just like it is. And your brilliant architecture is going to meet like a simple if statement that's going to say, hey, I need some like a random delay, maybe something specific, but it's going to be on a low-level API. And maybe your architecture, like your business logic, doesn't have access to that. Like your device communication layer does not expose enough low-level APIs to implement that. And what's going to happen next is that you're going to learn that there is a bunch of technical debt when you're working on an IoT project. Like the list just piles on. It's not like your like usual Jira ticket. Like there's like a bunch of issues. Here it's gonna explode, but finally you're gonna get a chance to do what's right, and the long-term game is called layering. Not sure if this picture represents it enough, but you need a lightweight wrapper around everything. And at first, this will feel like over-engineering. It really does. But in the long run, it's gonna pay off, because I guarantee if you don't predict it right now, in a year or so, the client will come up with some device that will need something that's really low level, and you will say, hey, I have this Bluetooth layer just laying around. I know I also have like a Zigbee abstraction or Matter abstraction over it, but I'm like future ready for everything. Anyways, now when you have like a perfect architecture, you also need to learn how to deal with raw data. In IoT, there's going to be a bunch of bytes. It's not going to be human readable. You need to prepare yourself for a lot of byte level decoding, which is, of course, custom parsers. And for like simple things, like you just need to instantiate an integer from a byte array. And just like this simple action also already raises a question, hey, does this use like big endian or little endian notation? Like there is already some like thought process just for this simple thing. Just imagine what's happened when you actually need to extract a lot of data from it. And of course, it's extremely hard to debug and it's a tedious work. Fortunately, I'm just gonna share some great tips that I started to use on my project, and that is for building the data, result builders. They came out at the same time as SwiftUI, I believe in the version earlier. It's an awesome thing for building data. Why? For example, if you check this last line, build expression, something called data representable, gives you like a plethora of options of building your own domain-specific languages. For example, let's just take this device name. Like you could hide this encoding in like simple initializer, and it doesn't show anywhere else. And when you check your code, like you're building the data, for example, this Bluetooth advertisement data, you can be a human and read this, and not just read this, you can just glimpse in it and understand what's happening. And of course, you're not gonna build data, you're gonna also work with, well, receiving data. And here, things get a bit complicated. For example, some of the low energy devices often use something called TLV structures. There's like a bunch of different protocols for encoding data, but what you need is like those embedded devices, they don't have enough memory, they don't have enough CPU power, they are just like, they need the least amount of possible overhead that you can get. And yeah, they are encoding the data, for example, like this. There is a tag length value structure. A tag usually represents, I don't know, a name of the device. You know that 01 stands for the name. Then you have a length that says this is how much you should read of the value afterwards that describes this value that's alongside with this TLV structure. And a really creative solution, at least I think it is this is completely inspired by Codable protocol. At least I would say it's a sophisticated solution. I pretty much ripped off everything that Codable did. And if you check the implementation, you can see that I have like TLV decodable. I have some data. I have some value. The data, of course, here is kind of like our primitive type. Like, for example, in a JSON, it's a string or an integer. You can see I have coding keys. You can ask me later why do I need case iterable here and all of that stuff. We can get into that, but if you take a look at the initializer, you can see that it pretty much matches one-to-one with like how would you parse a JSON for it codable, which I find really like creative and a neat solution, which brings me to my final point that I've been complaining about building IoT apps for quite some time now. And to be honest, it's not easy to work on an IoT project. There's like a lot of debugging, a lot of, I don't know, frustrations. But after all of those challenges, like you feel, it feels rewarding, like something works. And it feeds the innovation and creativity in you. At least that's something what I need to keep me like in this job. I need to innovate and create, and IoT just gives you that. Like you need, I don't know, custom byte parsers. There are not many apps that need that. And of course, the best thing of all is I think there is like a really, really bright future IoT apps, especially with, of course, AI. Apple is introducing App Intents. We already have foundation models. And what IoT devices do best is they generate a lot of data. Most of this data is not human readable. Average human probably can't recognize some of the patterns that are happening. So what could happen is AI could probably parse all this data. It could recognize patterns. The app itself could be like an AI-assisted interaction. And not just that, it could be even context aware. For example, let's say that you have a smart lighting system. The user knows that it's gonna use this light for, I don't know, reading in the living room. And it says, okay, configure this light, and I want this light to be like soothing to the eyes. The user doesn't need to know that the light temperature is, I don't know, is in kelvins. Doesn't need to know the science behind this. Like, it's context aware, and the best thing of all, it facilitates a really, really great adoption. And yeah, I like building IoT apps. Are there any questions? Are there any other fellow IoT developers among us?
One question. A few years ago, we worked on collecting some data from a wearable, right? Wearable, yeah, from a device, just
like a watch or something.
Data, yeah. It was Chinese, let's just say this. Everything worked correctly, but we had a problem when we wanted to retrieve paired devices. So you pair your app with the device, your phone with the device, and then when you try to reconnect, we had trouble retrieving paired devices. So we basically had to store the device ID and then turn on Bluetooth and search for the device by ID. Did you have any problems like this? Did you encounter anything like this?
To be honest, it doesn't come to mind, but Apple, like I said. Yeah, sure. So the question is, a few years ago, our fellow colleague had some difficulties with paired devices. After the device was paired, they had trouble reconnecting and retrieving some data. Did I understand that right?
Or basically getting all the paired devices.
Yeah, they just couldn't get the paired devices and the data from them. And to be honest, I didn't experience anything like this. What can I say about Apple is the way, for example, how they handle MAC address. You will get a UUID of the device, and this UUID is generated from a seed, a random seed, that's specific for each device. And that means that for the same MAC address, you're gonna get the same UUID based on that random seed. And maybe if you did it between different devices, exchange data, in that case you're gonna have troubles because the UUID does not translate. That's for privacy reasons. Not sure if that was your case. This is the closest thing that I can think of. I just didn't experience anything like that. We can talk later. Maybe we can come up with something better. Any other questions? Comments?
When doing anything with Bluetooth, always expect failures, without question. Write your code in a way that actually handles disconnects all the time. So basically, always have a background task thread, whatever you want, running, have it handle Bluetooth. Whenever disconnects happen, have it do whatever it needs to reconnect and do what, well, the app wanted it to do. So do not do that in the user interface. Have it completely decoupled, out of experience. And I did this code for millions of devices deployed. Well, millions, hundreds of thousands.
Yeah, the unfortunate nature of working with in IoT and of course working with Bluetooth is just the fragile nature of this, so you always need to prepare for the worst. And this is really, really obvious if, for example, there is like a lot of things that you need to do, like the specification for communication with the device is quite long and you don't know at which point the connection might drop. So it's like really tedious to figure out how to recover from that because there's like 1 trillion edge cases. So I understand your struggle. Yep. Brane doesn't need a microphone.
Yeah. Still, I'm going to use it. Nice presentation, thank you. I'm wondering, you were explaining how logs help you fix all these weird issues happening. Is there something more sophisticated you're using in production other than analytics that can give you logs on what's happening in some scenario when the crash happens or a device is not working, stuff like that?
In my case, I would say that analytics was a luxury. because the client
luxury.
was luxury because client was really privacy concerned and didn't want to do anything with Google or Firebase. So we had like a really primitive approach, or just keeping track of our log files locally and like having a management of those files to just not explode in size, but maintaining a certain size of those logs. And from the inside the app, we had a report a problem feature.
So it's a feature for the user to send you the logs on what happened.
Yeah, this is how we did it.
Cool, thanks.
Firebase would be a great.
Any more questions? Otherwise, thank you, Kristijan.
Thank you.